Hello and welcome. I'm going to write some more Haskell. Hopefully, it'll be better than last week. I just kill that. So last week was not the greatest I've ever been at writing Haskell. I was trying to swap out a concrete storage class to use a more abstract version based on a type class that I could then pull out of the application environment. And I just got in a mess. I didn't really know how to fix it. And then the thing when you're live streaming is it gets a bit more stressful. And when it goes badly wrong, then you get even more stressed and you don't think clearly and it just gets worse. Throughout the struggles with it, there were a couple of suggestions. There was a suggestion coming in the chat from Bernd saying I should be using a type variable when I'm declaring my application environment. And also I was Googling stuff. I realized after the event I wasn't sharing the browser, but in the background I was Googling stuff and trying to read how to fix it. And that was saying essentially that I should be putting the constraint on the function and not on the type. I didn't really understand what it meant. So I took some time over the weekend. I had a look at it in a more relaxed setting, and it was actually pretty straightforward to fix. I was just getting in a bit of kerfuffle. And I think the underlying problem here was that I was thinking about it in a very OO way. I was trying to write an interface like I would write an interface in Go or in Java. I don't really like Java, but it's the same kind of principle, where I was trying to say I have an abstract representation of some behavior and I would constrain that to some particular type class. And that's not really the way I should be approaching it. So let's have a quick look at what I'm trying to do and how I went wrong and how to fix it. And then I'll go back to the code and actually clean it up properly. Okay, so I have this, I guess I have this type. This is the key thing. So all of my functions are using this type called app, and it's just it's a reader T. It gets an environment and it gets some other monad, in this case IO. So when I have a function like load hosts, it's given the app and then it returns a list of hosts in this case. And it means I can do stuff with IO. So I can, if need be, I can say lift IO to get to IO inside the reader T, inside the app. But also I can get stuff out of the app-env. So I could say I could say something like B is asks, and then you can say num participants. Something like that. And that's how you can access the environment that gets passed around. Now my idea was, and it should have been quite straightforward, that I create a new type class, and let's call it storage, that's what it was called. It takes on a parameter and the definition of storage. I'll just simplify it slightly, but you can say you have a function called load. It goes from some x to a list of, I'm going to say a list of text. In this case, it's not quite that, but it's close enough for this little example. And then the idea is that you can then put storage into here. So it's a type storage. And then what I wanted to do inside here was say asks for storage. No, this isn't quite right because this storage is not quite a type in itself. It has to be something like storage S, but I don't know what this S is. So what I was trying to do last week is to write this as a type constraint. So I'd say, given some storage S, it's of type S. So I tried different variations on this, but essentially what I was trying to do is take this type constraint, storage, apply it to some variable, I'm just going to call it x for a second, and then say, whatever this storage thing is, needs to implement the storage interface. That doesn't work for a whole variety of reasons that I don't fully understand. I understand some reasons, but not all of them. So one suggestion was I should take a type parameter. I didn't really understand this properly. So what I was trying to do is say, okay, take a type parameter called s. Let's try and constrain it. So either something like this s must be something implement storage. Storage s would be like that, I think. That doesn't work. You can't do that. And then I try to constrain it here, which again doesn't work. You can't put this constraint inside here. When I try to put the constraint here, or when I try to do an extensional qualification, so say for all s, storage s, the compiler was suggesting some extensions, some language extensions that might make this work, but they were all wrong for my particular use case. So the solution is actually really simple. When I was saying put the type constraint on the function, I was trying to put it on this function. And that's not what I want to do at all. What I actually want to do is mix things up a bit. So I'll just have this type as s. And at the moment, s is polymorphic. We don't know what it is. And here, when I'm creating the type alias for app, I'll take an s and I'll just use it in here. So this is where the s comes from and how it gets passed down. Here, when I'm calling load hosts, this is the point where I need to put the type constraint. This is where I need to say storage s, and then we say app s hosts. So whatever gets passed in here, it needs to have the type constraint storage. And this is basically where I was going wrong last time. So this is where the constraint should live. And then now this should work. I think that's probably it. Like, there's a few more details when we actually write the proper code, but it's roughly that approach I want to take. So it's not super difficult to write. It's just that when I was doing it wrong, I wasn't understanding how to make it correct. Okay, so I'm going to pick up where I was last time, which is probably, is it in here? No, this is okay. So this storage class is fine. We have the storage interface. Yeah, the data type is the thing it's going to load. Because I was getting a bit stressed, I did a whole lot of other things that were wrong last time. So I'll fix them as I'm working through the code. So in application, we can make that change. We can say we take an s and we just add the s in there. And then here, when we're making app m, I think we can just say this. So it's given something which is storable. Actually, let me just fix them in order because there's an error coming up here. So when we create the app, we need to take an extra parameter and pass it in there. Okay, make app env. Let's do this. Okay, give them some s, returns that. I'm not sure I like this make app env. Let me come back to this later because I'm not sure I'll do this. In main, I can't remember how I fix this in user code now. So we get our arguments. This is called a make app m, which is not quite what I want to do. I don't think. So let me, instead of doing that, I'm just going to create it directly. So here, we already need to instantiate the concrete storage class that we're going to use. And I think, if memory serves me correctly, it was a thing called file storage. And I'm going to get rid of this nonsense because it's wrong. So, and that means we need to get rid of new type as well. So we can say data file storage, and it doesn't take any argument. Does it take any arguments? It could take the file path, but it doesn't need to yet. Does it? You know what? I'm going to give it file path. So what I'm thinking is we have this type, and when we construct this type, we tell it where the data is stored. So it's the path to the directory containing the different data files. So we can say new type that, and it takes a file path. Okay, let me implement this function on it. So loading something. It's going to return a list of storable things. So it's not going to take a file storage anymore. Yes, it is. Sorry, because the full signature of this is load x, where x is some kind of storable thing. It's not. Sorry, x is the thing that implements storage. Okay, so we're going to go from file storage to. It's going to be given the data type. And it's going to return a list of s's and run this under IO. Okay, we don't need to do this lookup because what will actually happen is we're going to be given the data type. So we know what the data types are. We can say s dot host was one of the data types. And if it's host, then we will load the hosts file. So we will say, I'll just say load. And then we got file storage, so we can say, let me just make this slightly easier to use. So I'll create a record. We'll say get file path. We'll get base directory. It's called base directory. Right, so down here when we're loading, we want to take the base directory, join it onto the file that stores hosts. We can just put in a file called hosts. I think it's actually a file called people. So maybe I'll put a file called people for now. So we'd say the base directory from our file storage joined onto the name of the file that stores the host information. Is it people? Let's call it go so we don't clash. And then we can say where go is equal to, I'm just going to switch to this so you can see more of the screen. Go is equal to maybe Marshall if.io read file in the path. So we need to pass the path into go. Okay. So that, I think, I'm a little bit concerned that we're not getting a warning here. I should be getting a warning saying this is partial. I haven't got all the matches, which means that something is very broken somewhere. In fact, probably many things are very broken somewhere. Let's go back to here. Right. Let me get rid of this for a second. Now again, that's a problem. Okay, this is actually doing more work than I thought, so I'm going to leave it in place. Okay, so this needs to return append just an append, where the append is going to take return that. Doesn't take any arguments. It'll have to take an argument. I'm pretty sure it'll have to take an argument because we need the type of thing it's creating. So best way of doing this, when we create the append, we want to pass in file storage. Essentially, when we create append, we want to say file storage, storage, name of the field, is equal to file storage, and then we'll instantiate file storage with some path. Because the constructor for this is simply append. So can I then return this? In fact, I wonder if I can put the type constraint here. So we can say storage as any storage, I think it's s.storage. And it's going to return, I can't return s because s is now, can return s. Right. And then here we'll take storage. We'll also call this s t, just to avoid clashes. Okay, and here we will export make append again. Okay, so in theory I can call make append with an instance of file storage. So make append with this thing. Okay, well, that works. And then when we call run t, that's the function, and the environment now should be append s, where s is now set to file storage at this point. I think. And we could even pass this in as this slash path. I'm not sure I want to pass in here. I kind of want it to work it out from here. So this would then be a function which goes from a file path to some s, and then we call the function and we pass in data directory, I think. There comes from data directory, and then she will say data dir at this point. Okay, I'm not going to follow that refactoring because it's a bit annoying. we could say storage is st applied to that. And should we write storage here? Okay, back to here. Now we should just build a pass in file path. Sorry, file storage. And it should then instantiate it properly, I think. Okay, I have a lot of errors. I'm just going to go and find out where those errors are and clean them up. Right. So now we have a problem. We don't really have a problem. All of these things take up, and up just it now needs an extra parameter. You need to tell it what the storage thing is. So I could say storable a storage s, and then I should be able to say app s that and put it everywhere. But I'm not actually using this anywhere. So I could do the same thing here. Now I do get the correct error. This is what I was hoping for originally. The non-exhaustive pattern matches. Okay. So we can put the other cases in. I would say the other thing we could load is a participant. So we'll take the base directory again, and we'll add people again, and then load sfs.topic. Here's go, baster, fs, and topics, I think. Let me just change these goes to load prime. So load prime now. I'm going to say load prime goes from storable s and it's going to say it's going to take a file storage. No, it's not. It's going to take a file pass. And it's going to return an IO of s. Then we can say load prime that, and so on. Okay. So now my instance of load should be okay. I don't really need this separate function because I could just put it directly into this interface. But maybe when this gets longer, it's going to be a bit of a pain because it's not just load that will be in here. Okay. So in theory, I have a lot of errors now, but it's going to be all of my apps. Every time I've used app, it's going to be broken now. So I wonder if there's a way I can do this without having to say this is storage. So for example, could I say just that and let it work it out? I don't know the answer to that, but let's find out. Just notice I've got storable A and storable S here. So I'll make these S's be A's. Just for consistency reason. Otherwise it'll confuse me later. And it's going to return a list of A's. Okay. So let's go and work through all the errors. Load hosts. Could be that. But actually, oh, that's cool. This is where we say, give me the storage class. This is the thing I wanted to use, I guess. And we call load from our storage. Pass in the storage object. And the type of thing we're loading is a host. And then here, I think we can do the same thing. I think I should have a type constraint here because I think you should say storage S. Because it's important that this S here implements storage because I'm going to use it. Load participants I could rewrite as well. I could say given some storage. And I don't call fs.load. I'm going to say S is ask storage. I need to do inside here. And then we'll say s.load again, our storage thing, and then we're going to load participants. All of these, I'm hoping I can just throw in S's, even though it doesn't make any sense. This is a little bit annoying. Okay. So couldn't match type S with host. Unless okay, I've got a clash here. So let's call this A. We go text A. Okay, that was just a clashing variable name. Right. So not in scope storage, but that should be okay because we can just add it to the list of imports. And I couldn't match type IO, so now we need to lift IO of that. And we need to import that. Something here, so we're going to lift this into IO because the storage doesn't run in app, it runs in IO. Well, this thing does anyway. Okay, load hosts, right. So because load hosts up here has got the constraint on S, this also needs a constraint on S, I think. Okay. And then load cast here. Okay, so because load cast is being used here, I need the same constraint. Storage S. It's s.storage S. Okay. Already in cast, so I'll need the constraint here as well. And because I'm calling it from here, I'll need the constraint here. Storage S. And how are we doing? One left. Okay, so at some point, all of these are loading something. And in order to load it, we need to implement, or we need to use this new type class. Okay. So next set of errors. This is now in loading the cast. So just going to load adding S's in here for now. Cast commands. Right. So run list hosts calls load hosts, which needs S to be storage. Need that constraint here. And storage as storage. Ooh, nasty. Too much. Different storage. Okay. I should be able to import qualified storage as S. Yep. Okay. So I'll need the constraint up here as well. And now I guess I need it everywhere. I guess they all called load at some point to make sure they weren't already in the list. Storage S. Okay, getting there. I got some unused imports. Oh yes, this is when I was doing weird things with maps. So let me remove all those. Okay, 3 errors remaining. So topics. Topic storage. We got add. We got list. So list is the load case. Let's go. Desktop storage. S. I think I've imported file storage as S. What did I do in host storage? Class storage. File storage is FS. Okay, so let me change this import. And then I should be able to import this. And now let me just fill in the S's. We don't really care what it is. Okay, I've renamed this import. So it's now FS and FS. And then here, what I want to do is say storage is asks storage. So import that. We got our S, so we should say S load. It takes S and it takes S dot topic, the type of thing we're loading. I mean to lift this into AO. And I need to import lift AO. Okay. Think okay. Okay, 2 errors remaining. Now in the commands version of topics, we have the same lack of constraints. So run list in particular is going to call storage.list, which has got this constraint. So we need storage S. And it'll be s.storage s. And we'll return something of app s. Okay, and the same thing here. A lot of typing. Okay, now it says no errors. Right, main. This is no errors. I see that to get an error. No, okay, so I need to restart LSP. Give it a second. Kind of okay. I mean, it doesn't work. But at least the LSP server is working. So if I say cabal build, it should give me some errors. containers is not needed. Okay, it's not the error expected. Cabal. Second. Okay, getting better, I think. So this should be file storage, I think. But before we get there, we have these problems. So these are going to call Haskell commands run host, and we know that's got a type constraint on it of storage. So in order to run a tool, this needs to be storage. And we'll make it s.storage. Okay, and then the same thing here, because this is calling load cast. I think this will also need storage. Okay, let's go. I give it explicit signature. So storage s. It's going to return s that. Okay, now data constructor is on scope, so we can import that. And now we have no errors. Seems unlikely, but let's try building it. It built. So I don't write any arguments. File does not exist, no such file directory. Okay, that's because I missed a slash off there. So that was in file storage. So it's base directory and people. I'll just put the slash into there. Build again. It's probably a function for joining files together. Anyway, interesting that works. So if I say hosts list, give me the hosts and participants list. Okay, that was a lot of work, but in here, in this cast thing, it doesn't know, well, when it's loading stuff, it doesn't know what the concrete type of this storage thing is. It just knows that it's something that implements this interface. And that's set when we call main. I might flip the arguments a little bit. So load takes the type of thing you want to load, and then this storage object. If I flip them around, then I can put it online. That would make me happy for no particular reason. So if I go to storage, look at definition load, it's actually going to be data type to X to that. Then we go to file storage. This should not be broken because it should actually be that. File storage, IO, and then just need to swap these around. There. Okay. So now we go back to here. That should be wrong. Why is that not giving me an error? Okay, that's the error expected. But I'm not getting it here. In load cast or load hosts. Why is that? Is the LSP server broken again? It was. Okay. Right, so I can swap these around. That should work. But actually S just comes from asks. So I can say asks storage and that goes into here. And that did not work. Is it because lift IO? Did lift IO go here? No, I cannot do that in a fancy way. That's annoying. What's the type of lift IO? Not that. That was one password. What's the shortcut for bringing up this? So something that's IO and then runs in M. This is something that's IO. Right, okay. I don't know how I'm going to get this argument into this position without passing it into lift IO. Okay, that's a bit annoying. I can't do it in one line. I live with 2 lines. Right. The reason for doing all this. I broke everything now. Well done. Let's make sure it builds. Yeah. So now I can kick the other piece over. It fixes itself. The reason for this is so I can write. Well, one reason is so I can write tests. So I can swap out this file storage with something that's an in-memory storage thing. So if we go to do a test, we do not. Let's make one. Test/main.hs. And I'm going to have to copy this. Let's start by copying. Oh, don't value it. No. That's that. Not that. Just want to open it so I can copy this test suite stuff. I thought copying from here would be easier. Just paste that in there. Okay, so it's not going to be cookie test. This is now a showtime test. The main is spec.hs. I'll have to rename it out. I could import shared properties, give them a bunch of stuff. So indent everything slightly so it lines up. I get it right. Yeah. Okay. So we need to type, we need to test directory, we need the main, we don't need that. Don't need that, we don't need that. We will need this. We won't have any other modules yet. Doesn't depend on base because that's in the shared properties. Doesn't depend on RELUde. It will need hspec. We don't need megaparsec, but we do need showtime. And then we don't need any of these. And the mode lines these up for me. Oops. No. Okay. I'll need to go and now grab nope, didn't mean to set up. I meant build. Okay, I need to run a test, but that's not what I want. Okay, so this main.hs was actually going to be called spec. And what did that look like? Look at bookie test spec.hs. This is a funny thing. Who knows? It did. Okay. So we have that. And then we have a look at one of the specs in here. So like server spec, time might be an easier one. It'd just be this, and we have a single function called spec, which is a type spec, and looks a bit like that. So what would this be called? This could be called like host spec. Host spec. And we won't import any of those things, but we'll import spec. Describe. Add hosts. It runs, and then we should say something like 4 should be 3. That should obviously fail. And then I'm going to say test. Should install a whole bunch of stuff. Spec.hs does not exist. I forgot to rename that, didn't I? Rename it to spec.hs. Spec into list, and didn't use showtime. Okay, get rid of that. And other modules was spec. Second. Okay, what's the problem now? Defaulting that integer. Oh, just what the times are. Okay. 4 should be 3. Wow, everything's overloaded. You can say let t equals, I guess we use an integer, right? I say t should be the integer 3. Hopefully that will work. Okay, we got failure. Good. Expect 3 over 4. Right. So, reason for doing that is I actually want to call, let's say, hosts. It lists hosts lists. Hosts can be listed. Okay. And then we should be able to say we will import from showtime, and we want import the host command thing. But I can't remember if that prints them out or returns them. It prints them out. It's not what I was told. Okay, so I'm going to put in the storage and load hosts. Let's start with that. Okay, so in the command file, we will now depend on show time. And then we should be able to say why can't I load that? Is that because Cabal won't run because I'm not using showtime? Yes. Okay. So I should be able to import cast.commands. And then from there I should say load hosts. I think. Hard to tell because it's so broken. But I should say load, that is load hosts. But we don't call run load hosts directly. We're going to have to call run reader t. Much in the same way as main did. So instead of calling run args, what we want to call is the load host thing directly, but we're going to have to give it an app environment, and that environment will need to be created passing in our mock storage. That's my plan. Let me just run compile test again, see if it compiles. Okay. Say H should be, and above a list of hosts. So let's say Bob and Betty. Will that now compile? Not scope, load hosts. Okay. So cast.commands is not what I wanted, it was cast.storage. And on reader t is not in scope. But at this point, hopefully this will load. Yes. Okay. Right. So it's not offering to import it, which means I need to add it in here as transformers. Transformers. And this is 0562 apparently. I seem to be spending most of my time just restarting LSP at the moment. But maybe I should update it. I think this has gone wrong. What have I gone wrong here? Because it's not used. It's not used because I can't import it. So I want control.monad and run reader t. I don't think this is quite right. Where did it come from? Control. So it's control monad transformers reader. I can get rid of asks. I'm not going to use that yet. Does that compile? Not quite. But does it get to the point where I can finish writing the code? It's better. Okay. So we got run reader t. Load hosts. and it wants to take the environment. So because we're running under IO, we can say env is makeup env. And it wants some kind of storage object. So it can say mock storage. Okay. So data mock storage is mock storage. And then we can say instance oh, I told it always takes file path. That's quite annoying. So make up env expects to take a file path. I mean, it goes from file path to storage thing. We can, I mean, we can fake that. We can say s.storage of mock storage where load, and what's over this, so it takes the type and it takes the mock storage. I'm actually going to make some map, I think. So this is going to be a map from string, maybe it's text actually, because I think it's text here. I'm going to go from text to list of text. And then I should be able just to, in fact, that would be useful if I'm storing things, but I'm only loading at the moment, so we don't need that. So we could say, if you're loading s.host from mock storage, then we'll say something like host 1 and host 2. Whereas if we're saying load anything else from mock storage is error not implemented. Just for now. So okay, it's going to be pure. And we're not using the mock storage yet. It really is just a constant. Okay. Now we want to throw in the first argument, so we can just use const for that. And here, right. So type of this thing is storable. So things that are storable are, for example, hosts. So storable A, S data type, mock storage, IO A. But let's make this explicit and just say now it's going to be I have host. Just import host, will that work? We won't do that. Where does host come from? This is going to be in cast. Here, is it exported? It is. I should be able to import cast.host. Qualified cast as cast. I don't need as cast. Cast.cast. Okay. And this should be cast.host. And this should be cast.host. Yeah, no, it's not really working. Not quite. That. It was host. No, can't do that. Oh, annoying. I just want to return some data. Okay. How do we construct these things? No, we should just have a type here, which is host. Sorry, constructor, which is host. Which is host. And it takes some value, some text. That should be fine. Let me save this. Doesn't know what the type is. I think that's what it's saying. Say this list of hosts. Can much type A with host, but host should be totally fine. Like host should implement storable. Let's do load host, mock hosts, mock list hosts, mock load host. And that's just going to be a list of hosts. So mock load host is equal to list containing host 1 and host 2. No instance for data string that is string host. What's that doing there? Got any suggestions? No. So why can it not infer that? Okay. So now I have my list of hosts available. I'm going to say pure mock load hosts. And it says it cannot do that. It cannot match type A with host. Even though this is some kind of storable thing. So storable A, list of A, they happen to be hosts. Relevant bindings, mock host list of A. No other relevant bindings. Okay. Here's a rigid type rule bound by the type signature for mock load hosts for all A, storable A, list of A. And I would have thought that host was defined is storable. Okay, let me just look at the definition of load host here. So load host here is giving me back a list of hosts. It doesn't say it's storable, it just says it's a list of hosts. didn't match type. It's really annoying. What's its problem? These should be hosts as well. That's definitely a thing. That wasn't causing a problem. Now I'm confused. I get rid of this for a second. And I have another function here called load prime, and it takes something which is storable and it goes ignore everything else. It goes list IO of A. Right, let's just do that. And then load prime, I will say mock load hosts, and you get the same problem. If I say host here, obviously going to be fine. So I don't know why I can't return a list of hosts as a list of A's where A is constrained to be storable. But in here, when the old way of doing it was just called file storage directly. So we call something like I'm just a bit confused now because the type signature of this is not saying that it's not returning an A, and this s.load is the thing I'm trying to replace. So the definition of load needs to take something that's storable and something that does storage on a data type and returns a list, by the way. There's a list of storable things. So if I go into file storage, its definition of load is calling this, which is calling unmarshal on whatever it gets out. So unmarshal is saying, given some text, return a storable. So can I use that inside the spec? So I make this list of host 1 and host 2 and just make those text, I think. For text. Oh, no, I can't. Because it's not in scope. I hope that's not a problem. import data dot text. See if it builds. It won't build properly, but see if it gets to the point where there's an error in the code, not an error in Cabal. Okay, I think that's right. Restart as P until we get to. Okay, so can I map Esther on Marshall over that? Not quite. So on Marshall, returns maybe. So was it map? Maybe I can't remember what was used. It's map maybe of on Marshall. Okay, and then I should be able to import this. Looking. It's the list of text. Okay, we're getting closer. Are we getting closer? Let's go back and see where it copies from. So on Marshall for hosts. Should be fine. Okay, so we given a list of lines, I think. Oh, not quite. So it takes a single piece of text and it strips the prefix off of it. Make sure that was host. If they're marshaled. Okay, so this is a normal list at this point. Okay. So here, let's say pure of map maybe S on Marshall. Okay, I'm not quite sure why that works. Why the other one didn't. We're good. Okay. We create our mock storage. I just run it now. It failed because it expected Bob and Betty and got host 1, host 2. So we change it to be Bob and Betty. And now I think the test should pass. Look at that, test passed. Okay, cool. So a lot of work, but I can now call the storage commands at the very least with mock storage, but in the application I can run file storage. So I started to make the separation between the concrete implementation of storage and the abstract storage type class. So next week I'll keep going with this, try and split things up a little bit more. I might actually get rid of this host prefix and just store them in separate files, but I can come to this later. I'll try and understand this a little bit better, why I needed to on Marshall rather than just passing a list of hosts. But I'll have a look at that as well. But yeah, that is to keep going with this and structure application better and make it so I can change the dependencies here, basically. Cool. So thanks for watching along. Yeah, and it went better than last week, even though it was a little bit awkward. Hopefully see you next time. Goodbye.